In this video, we will be going over domain and range from equations. But first, let's go over the key rules for domain and range. First, no 0 in the denominator. This is because any number divided by 0 is undefined. Number 2, even roots must be non-negative. For example, if we have the square root of x here, x must be non-negative. And why is that? Because this means one number multiplied by itself can give us x. For example, the square root of 9 here is going to be 3. What about the square root of a negative number like negative 9? Let's try negative 3 for it. So negative 3 squared gives us 9. And 3 squared also gives us 9. Just for trying stuff out, let's try 0 as well. 0 squared gives us 0. As you can see, the smallest number we can get is 0. So we're never going to get this negative number. As a result, it needs to be non-negative. Third, the domain of polynomials is usually all real numbers. A polynomial is a math expression that's made up of variables and coefficients. And what's important is that the exponent has to be a non-negative integral power. So some examples of polynomial are x cubed, 1/2 x squared, x plus 5, and so on. And 3, 2, and 1 here are all non-negative integral powers. Lastly, think about range after domain. It's often easier to find the range, aka the output of something, after we find the domain, which is the input. Now, let's start with our first problem. Y equals x squared minus 10. We start with the domain. As you can see, x squared minus 10 is a polynomial, so it's likely going to be all real numbers. As you can see, there's no square root, and there's nothing in the denominator or a fraction, so it's going to be all real numbers. So negative infinity to infinity. There's no restriction on the domain, so it's going to be all real numbers. Next, let's go through the range. The range is all the y values that this can be. So as you can see here, we have x squared minus 10. What do we think our range is going to be? What's the smallest that y can be? As you can see, we have an x squared here, which means x squared, at the smallest value, it's going to be a 0. So when x is 0, y is going to be negative 10. And we're going to make this a bracket, so we include a negative 10. What about when x is really big? Either really positive or really negative, right? That's going to get a super large value for y, and as a result, it's infinity. So our domain is negative infinity to infinity, and our range is negative 10 to infinity. Now, what about this question? We have y equals 1 over x plus 4. Like I said before, we can't have a 0 in the denominator, because 1 divided by 0 is undefined. So because of that, we know that x plus 4 cannot equal 0. And that seems to be our only restriction. So as you can see, x cannot equal negative 4. So we can write this as negative infinity to negative 4 union with negative 4 to infinity. As you can see, we're using parentheses here because we're not including negative 4 into the domain. Next, what about the range? What are the values that y can be given our domain? Do you see any restrictions? Yes, there's actually one restriction here. So our y, our range, can be anything but 0. And why is that? The reason is for y to be 0, the top needs to be 0, right? 0 divided by anything is 0. But in this case, we have a 1 on top, which means the top is never going to be 0, so y is never going to be 0. If you want to prove it to yourself, you could solve this, right? Let's plug in 0 for y equals 1 divided by x plus 4. So cross multiplying, we have 0 times x plus 4 equals 1. We get 0 equals 1, which is not a true statement, so the range can never be 0. As a result, our range is negative infinity to 0 union with 0 to infinity. For this question, we have y equals the square root of 3x plus 6. When we don't see a number here, it's automatically assumed to be a 2. So, knowing this, it's an even root. That means 3x plus 6 needs to be non-negative. So 3x plus 6 is greater than or equal to 0. Let's solve this to find our domain. We get 3x is greater than or equal to negative 6. Divide both sides by 3, and we get x is greater than or equal to negative 2. Our domain is negative 2 to infinity. Notice that we're using a bracket here because x is allowed to be negative 2. Because when x is negative 2, we get 0, which is non-negative. Now, let's take a look at the range. The range for this square root function is going to be anything that's 0 and greater. Why is that? Because the definition of a square root is that the radical symbol is designed to output only the non-negative value. So, because of that, we know that our range is 0 to infinity. For an example, because this only outputs the non-negative value, the square root of 9 would be 3. Even though negative 3 squared is also 9, when we do the square root, it's only going to output the non-negative value. Now, for this question, we have y equals x divided by x plus 6. As you can see, we have something in the denominator here that we have to take into account. Like I mentioned previously, the denominator cannot be 0. So we know x plus 6 cannot be 0. So we know that x cannot equal negative 6. Are there any other restrictions that we see? No, not really, which means our domain is everything but negative 6. And we're using a parentheses here, so negative 6 is not included in our domain. What about our range? What values can y be? So, it might be hard to see, but there's actually a specific value that cannot be part of the range. Y cannot be 1. And why is that? Let's take a look. For example, if we plug in 1 for y, we get y1 equals x divided by x plus 6. And if we multiply that out, we get x plus 6 equals x, subtract both sides by x, and we get 6 equals 0, which is a false statement. And the reason that we can see that the range can't be 1 is because x plus 6 here is always going to be a little bit bigger than x, right? No matter how big or small x is, x plus 6 is always bigger, and which is why y can never be equal to 1, because the top and bottom are never going to be equal. Now, for this question, we have y equals negative square root of x minus 7 plus 10. What's our domain? Let's start with the square root that we have. Like I mentioned before, this is an even square root, so x minus 7 here needs to be non-negative. So x minus 7 needs to be greater than or equal to 0, so x needs to be greater than or equal to 7. Our domain is going to be 7 to infinity. And this is a bracket because 7 here is included. Now, let's take a look at this range. We have negative the square root of x minus 7 plus 10. As you can see, like we mentioned before, this square root, right, the minimum value it can be is 0. And the maximum value it can be is like infinity. So, when this is 0, our y is going to be 10. And when this is really big, it's going to be negative a really big number plus 10, right? So our top of our range is going to be 10. And what's the bottom of our range? When x is really big, then it's going to be a negative really big number plus 10. So that's basically negative infinity. So our range is going to be negative infinity to 10. And it's a bracket because 10 is included, right when x equals 7. We've arrived at our final challenge question. Pause and see if you can find the answer. Now, let's get started. We start with our domain and we see whether there are restrictions. We have 2 restrictions here. As you can see, we have this restriction, x minus 2 has to be non-negative, And we also have the fact that x minus 5 needs to be not 0. Let's write that down. X minus 2 needs to be non-negative, so that means greater than or equal to 0. And x minus 5 cannot equal 0. So now let's solve. X is greater than or equal to 2 is the answer to this one. And x cannot equal 5 is this one. So now we have our domain. It's going to be everything that's 2 to 5, not including 5, and 5 to infinity. And we do the parentheses here because 5 is not included. Our domain is basically everything that's greater than or equal to 2 as long as it's not 5. So this is our domain. Now let's get started with range. This might seem like a lot, so why don't we break it up? For example, we'll test some x values and see what y values pop up. A good one to test could be 2, right? Because this brings our top to 0. So when x equals 2, y is going to equal 0 divided by 2 minus 5, which is 0. So we know that y being 0 is included, right? Another range we have is 2 to 5. So let's just say not including 2 or 5, right? Because we already accounted for 2 right here. So we're thinking something maybe like the number 4, right? Number 4, the numerator would be positive, and the bottom would be negative, right? Like 4, this would give us square root of 2, and the bottom would give us negative. So this would give us a negative number. But the thing is, how negative does it get, right? So as you can see, as we approach 5, not quite there, but maybe like 4.9, our top is going to be positive, and our bottom is going to be very small negative number. And that gets us to the point of basically negative infinity. For example, if we have like 4.9999, the square root of that divided by like negative 0.001, then we're going to get a really big negative number, which means negative infinity is also part of our answer. Now, why don't we think about this on the other range? So we have 5 to infinity here. So a number like 10, 20, whatever, right? So if we have a number that's bigger than 5, the top is going to be positive. And the bottom here is also going to be positive, right? Because x minus 5, if x is like, say, 6, it's going to be positive. And the question is, how big does this positive number get? If we have a number, say, like 1,000, 10,000, right? We have a number up top, and we have a number on the bottom, and it's also going to get really big. And because of that, we also get infinity. So basically, we have negative infinity to including 0 and 0 to positive infinity. Basically, we have no restriction for range. Our range is going to end up being negative infinity to infinity. Sometimes it's easier to break down range by trying different values for x and seeing what number comes up. And that's the end of today's video. Thank you so much for watching.